In this video, I'm going to show you how to find the unknown angle within a right angle triangle using trigonometry. So hopefully you've already worked out the lengths of sides. So now we need to move to an unknown angle. Now with these problems, what you need to know is we're going to be using the inverse of either cos, tan or sine. Well, let's have a look at an actual problem and see how far we can go before we need to use those inverse. So let's draw up a triangle. I'm going to draw a basic triangle where theta is the unknown angle and the length of the side is 3 meters and this side is 1.5 meters. Alright, so as always with right angle triangle, we look at the sides that we have the information on. This is the opposite and this is the adjacent. So writing down SOHCAHTOA, we decide which ratio we're going to use. Well, the one that involves adjacent and opposite is the tan ratio. So we write that down. Tan of the angle equals opposite divided by adjacent. Now, if I substitute the values in, the opposite is 1.5 and the adjacent is 3, I get tan of the angle equals 1.5 divided by the 3. Now I get to this point and I say, okay, tan of an angle equals this. So what angle will give me this ratio? So we're going to use the inverse function of tan. Inverse function of tan is tan to the minus 1. And I'm going to tan to the minus 1 of this to give me the angle. So I type that into my calculator. I inverse tan. Now to activate the inverse on a regular scientific calculator, you have to look above the sine, cos and tan button. So we look above the tan button and we should be able to see in yellow writing or some other colour writing depending on your calculator this tan to the minus 1. So you may have to press shift on your calculator to inverse. So press shift, inverse tan to the minus 1 and you get an open bracket, type 1.5 divided by 3 and you get the angle theta. And you have to ask yourself, is this a reasonable answer? So when I inverse tan I get 26.57 correct to 2 decimal places. It would be unreasonable for me to get a large answer above 90 degrees, and that's because only 180 degrees in a triangle. It would be unreasonable to get an answer above 90 as well, because 90 and 90 would make the 180 degrees. So you need to say to yourself, that's a reasonable answer. Let's try one more where we're using a different ratio. Let's draw a second right angle triangle with an angle down here. And again, let's put some measurements on. I'm going to go with 1.5 and 2.5. And we need to find this angle here. So let's look at the word SOHCAHTOA up here. We have the hypotenuse in this case, and we have the angle here. So this is the adjacent side. Adjacent and hypotenuse is the cosine ratio. So I'm going to be using the cosine ratio. And I know because I'm now finding an angle, I'm going to need to use the inverse cosine. So cos to the minus 1 of the adjacent divided by the hypotenuse, which is 1.5 divided by 2.5, will give me that unknown angle theta. So typing that in, again activate the shift button, we end up getting 53.13 degrees correct to 2 decimal places. Let's suppose you had a sine to use. So in that case we'd have the opposite and the hypotenuse. So let's do an example where we have an angle and we've been given the opposite, say 5, and the hypotenuse 7, say meters for argument's sake. Looking at this, opposite, hypotenuse, I'm going to use the sine function. I'm finding an inverse angle, so sine to the minus 1 of the opposite, which is 5, divided by the hypotenuse 7, will give me that unknown angle. Have to work that one out, so let's find my calculator here, and I'm going to do the inverse sine of 5 divided by 7, and I get 45, so theta equals 45.58 degrees correct to 2 decimal places. Summarising, inverse functions to find the angles, so you're using inverse sine, inverse cos, inverse tan.